Okay. Good evening. Good morning. Good afternoon. So it's already 4 o'clock a.m. and 7 p.m. in Nigeria. Okay. Welcome. Welcome, everyone. Okay. Welcome, everybody. So far it's just the 4 of us. I'm guessing okay. Precious is here. Nikachi is here. Keep it coming, guys.
Oh, I'm here.
Marvelous. You're here. So that's I'm guessing that's a confirmation that you can hear me. So it's good. Welcome everybody. So we're just 6 of us. Only 6 of us. Let's see if more people can join in. But while on that, can anyone let us know? Okay. So how was yesterday's class?
I won't lie, it was mind blowing. Like, I've been thinking, like, I wish every day would be like yesterday. Like, I know we need to increase and upgrade. So, yesterday.
Yeah. Well, we can't do it every day though. That's why it's once a month. That way, we still get to, have something, but I still also get to focus on my own life and personal stuff, So yeah. Well, welcome, guys. I'm glad that at least we understand it. We understand it. We're just 6 of us so far. Just 6 of us. And somebody came in and somebody left. I think just like I would always say, people, I like this, I want that, how can I, when can I, and all those questions. But when the chips fall, they don't show up, right? Someone said, just came on a Zoom meeting hosted foreigners, and I must say that we are the right track, because what they were talking about there was exactly what we talked about yesterday. Oh wow, that's interesting. Someone said, please, I can't hear you clearly. Someone, okay. Well, can you hear me now, Precious? Can you unmute yourself?
I cannot hear you. I cannot hear you clearly. As in, I'm stressing myself to hear you.
Can you hear me now? Can
Yes,
you
I can hear you small.
can you increase
Small,
your
just small.
phone's volume?
Yes, I've increased it.
And it's still low.
It's okay now. I can manage it now.
Mm.
Thank you.
Well, is it better now? Much better now?
Yeah.
Okay. That means I should
Good evening.
put the microphone straight to my mouth. Okay. Well, yeah. It wouldn't make sense that I would be talking rubbish, you know. And one of the beautiful things about truth is it's universal. And AI, it's a very beautiful domain, really beautiful. But then it's not just about beauty, it's about work. It's about doing the work, right? So I believe anybody who travels abroad to study would at some point venture into AI. And that's what it is. There's no missing words. There's no missing words. Because, okay, take for instance, I started doing AI since 2019. 2019. You know, over the time I've, published articles and all those things. That's still what I do. There's nothing else I do. So I believe yeah, that's what I do, since 2019. Eh, And I mean, think about it. So when I say, okay, this one is beginner and there's advanced, it kind of maybe not really makes sense yet, but over time, imagine when we have 12, 12 uh, workshops in a year. That's what it is. 12. And possibly in between, if we're up for it, we could have, in betweens if we're free and if we can. That means in 1 year, you've gathered like 12 sure uh, resources to help you probably for your future graduate studies, or even if you're looking for a job, at least you should know what you're looking for, right? So I'm guessing we'll just start off. We're just 7 of us, and we're not gonna wait for a person. Whoever shows up late shows up late. So let's keep it running. I'm gonna share my screen. I'm gonna share a tab. Okay, let me do this. So, uh, this is a capstone. Okay, okay. So this actually was one of the. So this is what I do to teach at KIT. For the workshops back then. This is not the actual title, but like I said, this will help us. I will share this code with you guys after this. So don't worry. So, how do I start? This is a Jupyter notebook, right? Can you see me? Can you guys see me?
Yeah, I
Yes,
can
we
see you.
can see you. We can see you.
Okay, but you can see virtually only the screen, right?
Yeah.
Yeah.
Beautiful. So, one second, let me check if there's anybody joining in. Okay. Okay. So, we're looking at this. This is where we import the two boxes. If you remember yesterday, I said for you to work, you need two boxes. And in Python, I believe by now, most of us are already familiar with importing libraries, right? So I'll run through what each of the uh, libraries do. NumPy, import NumPy as NP. This is, I imported it twice. Yeah, OS is twice. So sometimes there's two of them. So import NumPy. NumPy is a library for working with numbers. Numbers. You know how you solve mathematics with your hand? NumPy helps you do that, to compute additions, multiplications, square root, whatever on numbers. Matplotlib is a library for visualization, to see, to plot graph. And it's still the same. It helps us to read images. There's a library in it, a module that helps us for reading images. I am reading. OS is for file assessment. Anything that has to do with assessing folders, communicating with folders, paths in your computer. Yeah, you see here from the same OS, I can make directories and I can list directories. I'll show us what they do. From Shotil, import copy file. So this module, it's not really that popular, but it's really helpful here, right? And I'm going to show us. Is it in this project? But I'll show us. Random. Okay. So this helps us to either set a seed. That is, what it does is to help us limit the level of randomness in initialization, or set random. I'll show us. So similar to OS, path library also helps with that. I'm not sure if I use this, but I'll show us. From NumPy, import as array. We already know what NumPy does. Import system. TensorFlow. So this is where it gets more serious. TensorFlow is a library for machine learning and deep learning. Like I showed us yesterday. Similar with Keras, it helps us to build models in deep learning. This is same Keras. We can build convolutional neural network and some other modules to help us design a full network. Same with here. This is standard stochastic gradient descent. Keras for processing. So this also helps us to pre-process images. This is CV2. That is what's it called again? CV2 is a module for image processing. It's an image for it's a module for image processing. So it helps us to read images, analyze images. I've imported this before, so I'll take it out. I've imported this before. Take it out. I think I've also imported this as well. Yeah, take it out. Square root from NumPy, import. So I want to make it as simple as possible so that we don't have a messy script. So sklearn. So sklearn is also another machine learning domain But in this case, we didn't use it. We didn't use it. We used only TensorFlow. Seaborn. Seaborn is also for visualization, similar to Matplotlib. I don't think we used it, but still, let me remove it. I don't think we used it. Sklearn metrics. I don't think we used it, but I'll leave them in. Let me just make it more concise. So here are our importation libraries on Jupyter. Now I wouldn't run on showing us how to load this. We already know this. So what do? I hold my shift enter, then it runs. So when I run it, it revealed this. Now already my matplotlib has some errors. I'll still need to update it. That's why it's giving me some of these errors. You see, matplotlib is where there's a compromise somewhere. I modified it, so it's showing me errors. Now, the next thing we do is to read our data set. Where's our data? Now, what exactly are we doing? This is where the question comes in. What are we doing? So, let me show us what we're doing. Documents. Okay. Now, our goal today is to design a model that can recognize cats and dogs. That's the simple task we want to do today. You can see here there are pictures of cats, right? Cats everywhere. There are lots of images. So this is a computer vision project. There are lots of images, lots of cats. Look at dogs. So we want to build a model that can detect whether it's a cat or a dog. Right? And all those pictures are in the training data set. We have to test with images in the test data set, if that makes sense. So at this point, if you have any question, feel free to ask. Can you guys see me?
We can see you. Yeah, we can see you.
Were you able to see the folders?
No folder. I'm not seeing any. What we are seeing here is the code. Pattern lookers, all those.
Ah, okay. I just shared it. Let me share the screen instead, so it's easier, so we understand what I'm talking about. Somebody's microphone is on. Please switch it off. So this is the screen I'll share. Okay. All right. So if we're sharing the screen, then I'll just open the. Can you see this now?
Yeah, I can see it.
So this is the folder. Our goal is in chapter 1. I have the training folder. Inside this training folder are lots of images, pictures of cats everywhere. Cats and dogs, thousands of them. In total, we have over 25,000 pictures. So it's a lot of images. Like I told us yesterday, you need lots of data to train a model. This is just for cat and dog. And look at how many images we have. It's a lot. So after that, we can test with the images here. These are the tests. It will tell us whether it's a cat or a dog. So let's proceed. Having done that, then let's get back to business. You can see that this is where we stopped, right? Because someone's here. All right. So, using the OS module, I assigned it the folder to read, called its folder, and then use my OS to change directory to that folder. Someone's coming in. And with that, I'm able to list the directory, which is this. It's telling me everything, it's showing me everything in that folder. You can see here, all the things here, they are here. Those are all those things. You can see them. Right? So, at least now, I'm telling this project to focus on this path. This path. So, in your own computer, this is where you set your path. Okay? Where you set your path. So it will list everything in that folder. Now my train path is chapter1/train, which is the same thing as this. Look at it. Chapter 1 forward train. That's where the train is. Right? Similar to test, chapter 1 /test. So I'm following how my folder was structured to read my data. So I have my train path and I have my test path. Now label. Remember, we have two classes, which is cat and dog. So in this particular case, I'm going to use alpha and simp. So technically, let's say the cat is alpha and the simp is a dog, right? So we're using images of cat and dog to create a model that can tell us if this is an alpha or if this is a simp. Now, for us to understand what we're doing, let's visualize the samples, the photo samples. So, this custom code helps us to read the cat and also helps us to read the dog for you to visualize them. That is 330, that is 9 pictures of this and 9 pictures of this. 333, yeah. But I uncommented it. Remember, my matplotlib has issues. But if I'm gonna try. So, okay, here's what we'll do, right? I'm gonna run through this. Then we start afresh again based on where you're having questions. Now, if I read this, I have the folder, I read the train and test, and I define my labels. Remember, we're doing a classification task, which is binary, alpha and simp, cat and dog. That's why we have 2. If it's 3 classes, then we name them. So, this is where the magic starts happening. Some of us would wonder, why are we using images? How can the computer read images? So this is where we have a very, a little slight introduction into image processing. So let's focus on this card for a second. Man, looking at this, every colored image is a mix of 3 channels. That is red, blue, and green. RGB. Every colored image, but black and white, it doesn't have 3 channels. Look at this. Look at this here. To obtain an image in whatever color, in whatever texture, is a combination of red, blue, and green with different values, if that makes sense. So one image, we have 3 channels, in the sense that as an array, the goal is to compute the image into NumPy array, into numbers. Then we can work on it. So if I have multiple images, guess what happens? Because one image is row times column. That is, this is the row. This is the column, right? If I want to know the dimension of this is 3-dimensional, right? We can use, say, height, width, and depth, right? Height, width, and depth. Or row, column, channel. That is 3 channel. So to represent one image, it's in the form of row times column times channel. It's a 3-dimensional matrix. That makes sense. So one image, 3-dimensional matrices. Then multiple images is the number of examples. That's number of images times 3 dimensions. So to represent the whole images, it's going to have the shape. It's going to have 4 dimensions. Number of examples times row times column times channel. And if we understand that, then we can do that. So our goal now is to prepare the data. Our goal is to prepare the data. So these modules, we don't need them yet. So we take them elsewhere, somewhere. Don't worry, we're together. Yeah. So our goal is to prepare the data, which implies converting the images into what? NumPy arrays, right? Just like I showed here. And that's what we do here. So I define a custom function based on the path. So this path is where the images are. So if I say prep data train path, it's going to convert all the images in that path into NumPy array. So I have photos and I have labels. I give it a what's it called? Empty list, right? Empty list. Enumerate files in the directory. So for each file in the directory, right? Determine the class. Output is equal to 0 if the file starts with dog. Are we together? Sorry. Output is equal to 0 for every file in that what's it called? In the folder. But if it starts with dog, then output is 0. Otherwise, any other file there, of course, any other file starts with cat, the class would become 0. So cat is 0. If it starts with cat, then it's 0. If it starts with dog, then it is 1. Remember, I said binary class. So 2 classes, 0 and 1. If it is 3 classes, 0, 1, 2. If it's 5 classes, 0, 1, 2, 3, 4. Right? Then, if we understand that, then we load the images and resize it to 200 by 200. Some people do 214, 240. I just did 200. Some people even do 384. But the more you resize, the more the computation power required. So I convert each of those images into array, image to array, right? Then I store those photos using the append command. Also store the labels. At the end of the day, I return photos now as numpy array and labels. They accompanying labels for each of the photos. So if I run this command, which is here for the train, xtrain is the input data. This is the input label. If I run it for the train path, I will get the numpy array and the labels. So see here, we have 25,000 images, right? This is the dimension, height and width that we set 200 by 200 and 3 channels, red, blue, and green. 25,000 images corresponding 25,000 labels, if that makes sense. So I can do that here. Print shape of input matrices. This and let's say okay. And let's say shape of labels for the input matrices. So in this case, matrices are the photo. Don't forget photos, because we converted it from normal image to numpy array as a matrix. So if we run this, we'll get a better deal. We will run this from scratch again. I know why I'm waiting. So this is the shape of the image, 200 by 200, and we have 3 channels, row, column, channel, right? RBG, which is 3. That's why we have this here. Number of images, 25,000. Shape of the image, 200 by 200. and 3 channels. If this were to be black and white, this would be 1. But because it's colored, it is 3. Now, we've prepared our image for machine learning, for AI, for model design. And that is where we need to have conversations. Can anybody, if there's any confusion, someone should ask. Please feel free to ask. Please feel free to ask. Any question? Hello?
Good evening, sir.
Yes, good evening.
Okay, are we going to go through it again?
Yes, we will.
Okay.
Yes, we will. I want to make sure that so far we're together. Any other question so far? None? Okay. So, as we proceed, the goal is, it kind of, this is the basic. I'm being very honest. However, I know it's also a bit advanced for most of you. It's new to you. Right? It's new. Because me picking this does not mean that this is the most basic. We are jumping from introductory to image processing, computer vision. This is a little bit advanced for someone who just started. However, it's a simple task. Why I'm taking my time to build this and show this to you is to show you, 1, what is state of the art, 2, what is possible, and 3, those limitations. Like I want to use this to illustrate all those things I've taught yesterday. Right? There are very basic, like really basic tasks that could still be done. But with this, we can have an overview of everything I've explained. And I'll show you. So, now we've prepared our images because that's where the work is. You prepare your images or you prepare your table data, whatever it is you're preparing, in a way that it is understandable by the AI model. The AI model cannot receive raw image. No, you have to prepare those images as numbers, as matrices, and that is what we've done. So I don't know. Some people are coming and leaving. The idea here is for you to follow each step. Don't try to master it because that's what most people, tend to do. When it gets confusing, they try to master it right on the spot. Don't forget, I'll still post this on the what's it called? YouTube, right? Now, transfer learning is simply training a model and transferring that model to a new task. Now, we don't need to design a whole CNN model or try to design a model from scratch. There are already designed models built as modules, and most of them are available for use, which are this. We have the ResNet, Inception v3, VGG19, VGG16, Google Net. There are so many models that have been designed already. That's why I said AI is easy if you understand it. You don't need to start building a model by yourself. For images, there are so many models to pick from. You can see here, there are so many with their top one accuracy. All these models were trained using the same data set, and this is their accuracy. So we have several of them: ENET, ResNet 18, VGG 16. So the higher up you go, the better the accuracy on images. So we don't need to start creating a model, right? And that is what we did here. So instead of creating, we simply import ResNet, Inception v3, VGG 16, whichever one we like, right? But for this particular case, I'll show us the one I used. So I define a model, a function for training. And how do I do that? It's simple. Now, I can choose to work with any of these, but for illustration's sake, how about we create a simple model that can give us something similar? Because this is it's a very big model. Now, you open up the model, add a convolution layer, give it the input shape, right? This is the initializer, right? And you pad it. Take it to a max pooling, take it to a flattened layer, to the fully connected layer, and the output. If that makes sense. So this should be two. Oh wonder. This should be 2. So let's run it. Let's see if we can have something. Now, this is the shape of the model. I started training this one yesterday. Look, it's still running. It takes time. It takes time. So what I can do is to interrupt this. Let me restart and clear all outputs. And then show us what I'm doing. So we're starting afresh. If you remember, I said I'll start afresh. So what do we do first? Shift Enter. We import our libraries. Similar again, I have that matplotlib issue. And I will show you, if I list this, it shows me the folder, right? I'm seeing my data set. Let me read the train and tests and labels. That's it. Once I run it, it shows me that. Now, let me visualize. I run that. Let me see if it's going to work without it restarting my kernel. You see, the kernel appears to have died. And that is because of my matplotlib. My matplotlib keeps killing my kernel. But if I use it on PyCharm, it doesn't do it. So if you run this in yours, it's going to show you the images. Let me even try something. This computer. if I can install a fresh one. Hmm. So I know that now it's getting a little bit um hard, right? Uh, Precious left. Okay. Where is it? Okay. Okay, it's installing. You know, while we wait for it to run, most of us think that AI is, oh, you you plug in your picture online, it gives you all those things. This is the back end. This is the basic of what you receive online. As to why some people would be like, why are these websites not for free? Some people would wonder, oh, they made this and they ask you to pay because it's not easy. This is where the work is. And if you're looking for jobs in AI, you're looking for scholarships, they don't expect you to come and click on websites and click and click and click and then you get results and then you give them and they pay you money. That's not how it works. This is the job. You have to understand how to process your images, how to design models, debug, and all those things. It's not, of course, it's not easy. But if you start, then it starts making sense. And then you start loving it. And then you start getting paid for it. I'm being honest. So while this concludes, uh, it's not. My matplotlib is messed up. I think I would have to manually remove it. I want to see if we can show this. I want to show the images. However, in your code, it will show. In fact, this should be your assignment. I'm very sure it will show. So let's continue. If you remember, we ran through this. I've explained this. Then let's return. Let's do this. If we define this function to convert the images to what's it called? To arrays, we run it. Because there are so many images, it's taking time. Now you see why I keep telling us get a computer with high computation power. Mine is Core i7, 16 gig RAM. See, it's taking time. And it has a GPU, right? But still, only to load the images, to run to convert them from what's it called? From images to array, it's taking time. See, so while we wait for that, I think okay, yeah. While we wait for that, Mm. You can see it's taking time, right? It's taking time. So let's see. It's going to complete very soon. That is why it's a job. Nobody gets you paid for doing a simple task. So by the time it's done, it's going to print it out for us. Oh, this is taking so much time. Taking so much time. Damn. It's taking forever. Okay. We have 10 more minutes for us to conclude. We're almost done. Damn. While we wait for that, let me create the next link. And I'm going to appreciate it if you have questions. Remember, the goal is not for you to master it in one try, it's for you to understand it. If you can't build a model or at least have understand a framework that differentiates between cat and dog, I think that should be the beginning. You know, that should be the beginning of your AI task, right? So, oh God, it's taking a lot of time.
Okay, so I have a question.
Yeah, please go ahead.
Can you scroll up to where you loaded the data?
Here,
Yes, yes. Okay. This why did you use OS? What is this? Is this OS is a library?
yes,
Okay. What is this? Is it used for?
it's for assessing path. You can change the
Okay.
directory, your root directory, where to focus on for the project. You can,
Okay.
that is what this does. Change directory. So it you're given the command that my project focus on this folder. This is where I'm working. So focus here. It's better than having an open uh, project that can access any and every file.
Okay.
Mm.
Then under is the list directly is used to
Yes,
list it out.
just to show, yeah, show everything in there. I can take that out, or put that in
I'm going to list it.
if mm, just to list it. So I'll know for sure that that is what I'm doing. And that's why I recommend Jupyter Notebook, because for every cell, you get to see what you're doing. Yeah, that's a good question. So this is taking forever. I think it's already no. Let's restart it. It's taking too much time. It's taking too much time. Hmm. No wonder. Okay. Let's restart again. No wonder. Okay. Let's run this. Yeah. Okay. Should give us something soon. So well, since it's taking forever, so of course after that we pre-process. This is to help it improve discriminants. Like I said, image processing is very necessary. That way, there are there are basic pre-processing steps. You normalize them, you standardize them. There's so many things to be done. Maybe you try to change the brightness, contrast, so on and so forth. At this point, I can't start showing you all the image processing techniques. With this, ResNet.preprocess, it gives us some of the basic preprocessing tools that when you run it, it can better produce images as arrays that are already discriminative. So we process it, and then we have our model. I'm just wondering why this thing is taking forever. All I need to see is the shape of the data, and I wonder why it's taking time. So whenever you see this star, just know that it is it's running. And see this, it's black. See kernel busy, so it's still running. I don't know why. So we proceed, we create our model, right? So after creating the model, we can save it. So this is another step. You can't spend time designing and training and you don't save your model. That's going to be stressful. So I already have one saved, but it is not optimal because remember, there was one here. It was an error on my part. There was one here. Supposed to be two because two classes, but I put in one. So I trained a model that will only identify one class. So, God, why is this doing this?
Okay, sir. Question.
Yeah, please go ahead.
I'm noticing that working um, with images is
Hmm.
kind of more tasking or more difficult than working with numbers.
Yes, yes, because one single image is already a three-dimensional matrix. So it's a lot of numbers. But for table data, it's just matrix. It's easier, simpler. And that is the part where I personally want us to go to in our next what's it called? Our next workshop on AI. The reason is for table data, we need to explore several statistical methods for feature engineering, you know, and also to analyze the data. So for image data, the task is often channeled towards statistical processes for uh, feature engineering, right? But for us to proceed, I think we have uh, to create a new, what's it called, link for us to for us to continue. So what I'll do is I'll paste the new link in the group, and then we end this. So let's all exit and rejoin. See ya. Ọ kwa ezigbo egwu ka onye a na-akpọ egwu ndị ụwa. Daniel egwu ga-atọ ọnya. This is your music. So okay. Let me share my screen. Okay. So, okay. On the right track. So I'm going to share my screen. Welcome back, people. Let's give it a run through. So this is the screen I'm sharing. Right? This is where we stopped, bah? This is where we stopped. So, it's still running. I don't know why, but it's taking forever. It's really taking forever. And this has never happened. I just want to show you guys the shape of how it looks. Because without this, we're not proceeding. Okay. While I explain, where are they? Okay. Admit. Okay. Admit. So more people are joining in. And yeah. So this is where we are. Excuse me. Oof. It's early morning here. Okay, thank God. You can see it's loaded, right?
Yes, we're here.
You can see that the shape of the input photos. We have 25,000 images. Oh God, that's a lot. Each image is 200 by 200. And for that 200 by 200, there are 3 channels. So if you want to find out the total number of numbers that make up this is 25,000 times 200 times 200 times 3. That's the total number of numbers that make up the whole images. One image makes up 200 times 200. That is about 40,000 already times 3. 40,000 times 3 is 120,000 numbers make up one image. Then you multiply it by 25,000. That's the total number of numbers. You see that's why it takes time. And that's why you need computing power. See it now. So after doing that, we can pre-process our image for classification. This is easier. And now we want to build our model. I explained this before. I just use only one convolutional layer, just one hidden layer. Because if we keep building, VGG16 has 16 blocks. 16 blocks of this. 16. VGG19 has 19. ResNet 18 has 18. ResNet 50 has 50. You see that the more you're building your model, the more it takes computation power. So let's build a simple model, just one layer to predict two classes. If we run this, it's going to train. So see. So I only do 2 epochs. I want it to run twice. What is this? Autograph. Labels must have maximum. One second. This should be it. Just hold on. Agmax. Give me a second. Here. Second. Oh, that was my bad. Okay. Because it has one dimension. Give it 1. So let's train. So you can see now. At the screen, you can see it's training. You can see the arrow. It's going to come. I'm only using 2 epochs. 2 epochs. And the 2 epochs is I want it to run twice. So what training means, if you remember when I talked about gradient descent, looking for the global minima and all those things, that is the location of minimum error. It's not something that happens instantly. It has to run over iterations several times, back and forth. Gradually, the loss would go down. Now, take a look at this number. Now, I want you to, okay. Let's focus on, let's focus on this number. You can see it, right? As it is running, this loss is going down. And accuracy is increasing. So the more iterations, the more the accuracy gets better, the loss gets lesser. That is what we call training. Now, I cannot guarantee that by the time this thing runs, we would have very high accuracy and very low loss. But I can guarantee that if this epoch were to be 200, it means you're running this process up to 200. And that means you definitely get a well-trained model. Because ask yourself, how do you learn? It is by repetition. It is by repetition. You read chapter 1, you don't really understand. You read another again. You keep practicing. That is how you get better. Just like somebody who is learning how to dance. You don't just know how to dance because you see or you heard music. You have to gradually practice. That means you're training yourself. That is exactly what's happening here. The loss is going down, accuracy is going high. Also, remember, this is illustration. In our next class, in our next workshop, that's where I'll focus on. Let's do each step of the way. We see everything. Okay, yeah, question. Please go ahead.
Okay, sir. What does it take for you to increase? You said the epoch, you're only using 2 here.
Yeah.
Is it because of the RAM of your computer, or
because of time? This thing is just one epoch. One epoch is taking this time. You see the second epoch. Now imagine if we have 200.
Wow.
So training takes time. That's why you are advised to save it. You see now. So that is why it's a job. Now imagine building a rubbish model and you spend weeks training only for you to say, oh, I made a mistake. You might get fired. That's why it's a job, like it's a task. Mind you, this is a simple task. There are projects that will require more than one computer. You see some people having 200 GPUs, 200 supercomputers linked just for training. In the school now, okay, my project, what I'm doing, I can't even train with my computer. My computer can't train it. That's why I have to go to the school and connect to the supercomputer that the school hosts remotely. That's where I train. So, if I'm being like this, you are seeing that it's not just, I have a small computer that will run. Yeah, small computers, they are good for table data. For most table data. But when you go into image, video, forget it. You need a supercomputer. See, so the first epoch has run through successfully. We'll see the second one now. So in the second epoch, it's going to start again. It's going to start. Oh yeah. I think this is really dragging my memory. But it's possible for me because my computer has a GPU. Has a here you see now. So for every epoch, it will check validation. you see that I still have 86% error and 0% accuracy. So my model is not really, this model is not really doing the work. If you get what I mean, I'll need to run it through several epochs so that this thing can keep going down, can keep going up while this goes down. You see that loss has gone from 90 to 0 point. Yeah. While this, fluctuates up around 60 something percent on the training. So the goal is to, as much as possible, achieve 100% accuracy on the training. That way, when you test, you can get a good validation. Validation accuracy and very low validation loss. Because we can see here, if you have 86% error, it's not yet good enough. You can see that this one is going up a little bit. It's going up compared to this. So I think it's gotten to the peak of its strength. This model is now, it's not really that strong to train this, right? And that's where it may be necessary to employ any of these. It may be necessary to employ all those predefined models, but it's going to take more time. It's going to take even more time. So, but why I said I'm going to share this code with you is so that you can see in case of future, if you want it, if you have a GPU, you can experiment with it. If not, just watch the video and, still follow along and understand it. Possibly by our next class, then we can work on simple table data, maybe for stock data. Or in fact, I'm going to give us the privilege of giving me a data set that I should work on. Then I'll use that to teach us, if that makes sense. Maybe someone can get a data set, table data, then we can work on that. I think that could be done. So after this second epoch, let's see what happens.
Can it be okay? All right.
Okay. Please go on.
Okay. Can it be in Excel or just can it be any data set?
Excel, yes.
Okay.
CSV, yes.
Okay.
Most data sets are in Excel, so it's okay. Most of them. So yeah, just give me a data set. Let me see if I can get something out with it. Or there's the COVID-19 data set from Korea. There are lots of data sets. Just get me one. Let's do that. So after the training, our goal is to save it. Right? When we save it, we can load it when we want to. So in this case, I had already trained this model before, but it wasn't really that good. It wasn't good because it will take forever. I trained it with 20 epochs with that basic model. So I don't think it will give me the, how do I put it? The robustness for predicting. Right? Now, if you ask me, is this project a successful project? Can I rely on this model for detecting cats and dogs? No. And I'll leave us to give me suggestions on why it is not reliable. And I'll show us From its performance, we will know if it's reliable or not. Okay. I think it's trained, but it has to end. So let me save this to epoch model. Okay. Okay, so it's trained. And we save it as this times 2. So we load the model. This one is the one I trained before. This one is saved as model 2. So if I want to call it, okay, let's call it model 2. We call it. Now this will show us the history of training. Remember, my matplotlib has issues. So if I plot it, it will kill my kernel. But if you run it in yours, it's going to run. Now, the goal now is to test on random images. I want to test. So, test path. Oh, no wonder. Chapter. No, I don't need to. Well, we've already said this before. So, this function helps me to test on it. I test on that. Shouldn't be here. So let me run the test on, remember the test folder, chapter 1. We have tests. We have 1, 2, 3, 4, 5, 6, 7 images. Let me show us. Let me stop sharing this and show us the particular, the entire screen. At this point, it's better. Let's share the entire screen such that we can see this. Right? This is our test folder. Right? We have these images. So image 1, see the name 1 is a dog. Image 2 is a dog. 3 is a dog. Image 5 is a cat. Image 6 is a cat. 7 is a cat. So 1 to 3, dog. 5 to 7, cat. Let's test. So 6 should be a cat, right? 6.jpg should be a cat. That is like this. 6 should be a cat, right? So let's test if our model can predict it. So remember, 0 is what? Cat. You remember? This is what I mean. When we were doing the labeling, remember here, 0 is cat and 1 is dog, right? So we've tested for cat. The model is able to predict cat. Dog is what? Let's use 2. 2 is a dog. It still says it's a cat. What do we think? It tells us that this model, for some reason, has errors. Is not efficient. And that is born from 1, we trained over a little iteration. Look at it. The loss is very high. Accuracy is 0. The model couldn't train it very well because it didn't run through several iterations. In addition, The model itself is a weak model. It's just one layer of convolution. Only one layer. But if I show you something, let me show you no. Let me show you something so you understand what I'm talking about. Okay, let me open this. And no. Take for instance this. No. Take for instance this. Let's see something. This is another project. I want to get the model. Where is it? Oh my god. I would have to run this thing again. I've uncommented distance. Let's see. ResNet 50 architecture. Take for instance. Let's see how it looks like. What ResNet looks like. Image. Let's look at this. Let me pick this one. All right. Well, let me pick the one that can. Okay. Let's look at this. Okay. This is a full ResNet 50, right? 50 layers. Now, what we did in our own is just one block of this. That's our model. But this is a whole ResNet. Do you get what I'm saying? So this model would definitely do much better than just one. And that is where you can see it here. This is just one block. Come 2D, max pool, flatten. Let's look at it. Conv. So, of course, max pool has to come between this. So these are one convolution block, another convolution block, convolution block, convolution block. From this to this. This is a deep learning model. Very deep. Therefore, it will require more computation power to use. And that is where this becomes a problem. It is limited. So this is the reason why the model itself cannot be able to predict perfectly dog and cat, if that makes sense. Any questions? Do we have any questions? Do we have any questions? Any questions, guys? No question from you, okay? But I'm assuming that we all followed. I believe this is, although it's a little bit advanced, it looks advanced, right? It looks advanced. And this is not something that it's easy. That is why you need to practice your coding, but most importantly, understand what you're doing you need to understand what you're doing, know how to use libraries. Yeah, it is more complex, yes. Working with it, working on images is more complex, I'll be honest. Doing it practically. But for the overall structure is easy to understand. Get images, label them 1 and 0. Create a model, train it with those images, and predict. It's a very simple framework, but the back end, doing it is a bit harder. Now, like I said, this is not a tutorial to teach you computer vision yet. No. This is to illustrate to you the importance of training data, modeling, overfitting. In this case, there's an underfit. There's an underfit because the model couldn't fit well into the training data. Right? The importance of activation function. Here they are. I use ReLU for the dense layers and sigmoid at the last layer. So, this is part of why the model. You can see here, okay, total parameters 40 million. 40. So, okay, oh yeah, somebody has a question.
Okay, sir, it's based on underfitted model and overfitted model.
Yeah.
I wanted to ask, underfitted model means the model has low training accuracy and low testing accuracy. And then overfitted model means that the model has high training accuracy but low testing accuracy.
Can you come again?
Okay, I'm saying overfitted model means that does it mean that the model has high training accuracy but a low testing accuracy? Then underfitted means that the model has both low training accuracy and low testing accuracy.
Yes, for sure. An underfit has, I wouldn't say tests, I'll use validation. Validation. An underfit is when there's low validation accuracy. An underfit. However, overfit is when there's, let me say, perfect training accuracy, perfect validation, perfect tests. Right? The reason being, it's more like a perfect model which doesn't exist. So how you get to know about overfit? It's like you draw a straight line graph, 1 point here, 1 point there. If what's it called? Physics graph. An overfit would be to make sure that all those points enter. Therefore, you are trying to build a model that is perfect for that particular data alone. So if you give it a data that is not like that data, it will perform poorly, very much poorly, because it is overfitted to suit that particular special instance. That's why overfitting is a problem. But if you have a generalization, it's like when somebody says, yeah, I'm glad you got it. You know, someone could just say that men lie. It's a generalization that is valid, but that does not mean that all men lie or that all men cheat. But somebody can say men cheat. Some people might take it positively, some people might take it wrongly, but a majority generalization based on what's happening, we can say that men cheat or men lie based on what we hear. But however, in reality, studies have shown that men cheat as equally as women cheat. Do you see it now? But if I say men cheat, it could be that it's a generalization that is true. Because men cheat and women cheat, yes, but men cheat. But if I say men cheat more than women, it's kind of similar. But that doesn't mean that women cheat. So having a natural balance shouldn't involve an overfit. Because when somebody says men cheat, what they are trying to say is that every man cheats and no woman cheats. That's the extreme. That's an overfit. And that's wrong. So, but natural balance should be to what degree? Let's say 50%, 60%, but it still doesn't invalidate the fact that that happens, if that makes sense. So the goal is to create a model that can, as much as possible, achieve a natural model that can be transferable, if that makes sense. More questions? More questions? Can we have more questions? Well, we're just 9 of us. And I know it's not easy. It's not easy. Okay.
Okay, sir.
We're just 8 of us. 8 of us.
This model you just created now,
Yeah.
how will you improve it? What will you do now to make it better?
That's a good question. To make it better, what I could do is 1, work on an established big model like the one I showed us before, right? Use a bigger model or stack up more models here. This is one conv layer. I can stack up more. The next layer, build more layers by myself, right? I can do that, or I can use any of these models. Inception v3, ResNet, VGG16, VGG19, and so many other already built models. I can use those ones. But the only problem is it's going to require computation power. Right? That's 1. 2 is I can also increase the epoch size from 2 to 200 so that it can train over several iterations. So it can practice more on the training data and get better results. So these are the 2 major ways you can get this model to do better. If that makes sense. So what I can promise us is, how about over time, I would make this model better, maybe use ResNet and all those things. Increase the epoch, run it. Probably it's going to take 1 day, a whole day or 2 days, and then get a good model that I can share with you guys. So that, I mean, why not have it? I'm not doing anything with it because cat and dog model, I don't need it. It's not for me. This is what I do. I do the plant stuff, right? So I believe this creates, an avenue for us to understand what's going on. How is it learning? This is stochastic gradient descent. This is the learning rate. This is its momentum. So this provides us, yes, everything we talk about is actually doable on Python. Not so easy, but it's doable. So if you practice and keep practicing, then yeah, please go ahead. Question.
Okay, sir. That means when the model is ready now, I can just get a picture of maybe a dog or a cat, then I can check it and it will give me the correct
Absolutely.
whether I say it. Okay.
Absolutely.
Let me say you're working for a company now, and this is what the company said it should do. You should just make this model that can predict a dog and a cat. How will you now, when you are through with the model, how will you now give them the model? Like, how will you now share it to them so that they will have it? Or how do they do it?
Good question. So what? Because I saved it, I'll show you that model. This is it. The size is about 320 megabytes. So there's two of them, right? 1 and 2. I just take this file, give to them, and also give them this script, especially this part. I'll give them this. And they test it. Run test. They'll know. Easy. You see?
Okay, our own is just to create the model and give them the file of the model.
Yeah.
They now know how to go about it.
Not really. I mean, you should be able to produce this script. This. You should be able to have a file, a Python script that can read the model, read their tests data, and then give them results based on what you've built. Actually, when I was in Korea,